Okay, as you noticed, I just changed the, the presentation a bit. I was under the impression I was going to be speaking mostly to nursery people, but it sounds like you want to know more about bees and pesticides, so I added a few slides on that. And it's interesting to me, I just came from the National Beekeeping Convention, spoke several times there, where it's a large group of people where every single person knows me, and I walk into here to a large group of people where nobody knows me. It's a real different. Also, you're a little bit younger bit. Beekeepers tend to be on the older side, 50s, 60s, and up. And we're always looking for young people to come in, but it tends to be a little bit older audience. So what I did is I put together a presentation specifically on neonics and nurseries. But you guys, at any point, you can just holler out and let me know if you have any questions. I'd be happy to answer them. So first thing to understand is that in nature, there's no such thing as a pest. Pest is totally a man-created construct. And pest came about when we try to grow crops in monocultures of one species of plant in a large expanse and do it year after year. Then the natural balance of nature is thrown off because you don't have this give and take on the food supply. And normally when a monoculture happens in nature, then the herbivores move in and bring it back into balance. Well, when they do that, when you're trying to grow something for a profit, you consider that animal a pest and try to do something about that. It was really tough doing monocultures. Farming was very mixed early on, until during World War II, when the organochlorine insecticides, the neurotoxins, were invented, and everybody just loved them. They were just magic. All of a sudden, they made farming, they made pest control, mosquito control really, really easy, and it just revolutionized agriculture. Part of the green revolution that brought about us being able to expand our human population and eliminate much of the famine. Unfortunately, any kind of pesticide there is has side effects on the environment. Some have more, some have less. The ones that are of most concern were the persistent organic pollutants, or the POPs. And the environmental regulators throughout the world got together and realized that these things are building up, that you spray DDT or chloridane, and it has a half-life of like 40 years out in the soil. And when they wanted to do experiments with human beings to see what effect low levels of DDT had in your body fat, and they looked for a human control group, there were no control groups on the planet Earth. Every human being, even in the Arctic and the rainforest, had DDT in their body fat. We had essentially put it into every organism on Earth. So you couldn't even do a control group to find out. The group that showed the effects the quickest were the raptors and the pelicans that affected the calcium metabolism for their eggs. And then a book was written, Silent Spring, by Rachel Carson, and this kicked off the environmental movement and really brought things to people's attention. Now, the thing to keep in mind here is this was about these organochlorines, which had a really, really long half-life in nature, and they did something else. They bioaccumulated. So like in a food chain, it typically takes X amount of biomass for this trophic level of, say, plants, and you have maybe 1/10 the biomass of the next trophic level, the herbivores, and then the predators on that have maybe 1/10 of that biomass, and the next predators have 1/10 of that. When the plants absorb these organochlorine compounds, they're bioconcentrated or bioaccumulated at each level of the trophic level, and they concentrate. So the animals at the apex of the food chain, the raptors, the carnivores, they tend to accumulate it at these organochlorines at a very high level, and that's why the bald eagles at the top of the food chain had a problem with this. The public conflates a lot of the pesticide issues now with this, and keep this in mind. Most of the pesticides we use now do not bioaccumulate in the environment, but the public hasn't resonated with that. What we've done is we've phased out most of the persistent organic pollutants. The organochlorines aren't even on here anymore. The organophosphates, which replace the organochlorines, we've been phasing them down lower and lower. California is down to we're down just a couple of organophosphates, and they're looking at phasing that one out. One of them is registered for use by beekeepers, of all people, and wound up becoming a problem in beehives to the beekeepers' concern. And then other insecticides are increasing. We have new generations of insecticides coming along, the biologicals, insect growth regulators, and the neonics being one of these. In order to replace these, we're also phasing out the carbamates too. Those won't be around too much longer either. So we're witnessing this evolution of pesticides as chemists invent new ones, as we understand the biology of pests and plants better, and then as we understand the environmental ramifications. The next generation is all going to be RNA and genetic engineering. The possibilities for pest management without putting any toxins in the environment are absolutely amazing. I'm working with a group right now. We're working on developing products right now that will just be absolutely environmentally safe, that biodegrade almost immediately, and very species specific. Those are just starting to, we'll be hitting. Monsanto has one, and they just started the regulatory process of that. By the way, I pissed off Monsanto because, real bad. I was really good friends with them, and then I really pissed them off because I wrote a letter on a comment section with EPA about that next class of the RNAi products, and me being involved in it, I knew a lot about it, and I said, you know what? Don't make the same mistake you made with genetically engineered crops and get the public afraid of it. You have to be really transparent about bringing these into use, because they could be of huge benefit environmentally, and the public is so distrustful that you have to be very careful. Well, Monsanto didn't like having to go through more hoops to do this. It's interesting. Something I see is the EPA, whenever they have a question, they have a comment period for accepting public comments, and they say right on the comment page, don't bother signing petitions, essentially. They don't say it in so many words, but essentially they just go into the round filing cabinet, but write a good letter. And I've written 3 letters in the last couple of years. When I speak to the EPA risk assessors, they can cite my letters word for word, okay? So if you write one good letter, it has way more impact than a million signatures on a form chain letter. California is looking to take out chlorpyrifos, Dursban, very widely used. It's going to be harder and harder, I'll tell you right now, for pest management as they phase these insecticides out. So you guys want to stay on the learning curve all the time with being able to use integrated pest management using gentler next generation insecticides and miticides, fungicides. We're still way too dependent. Most pesticides used are herbicides across the world by far. Insecticides are just a small portion of this, and I think these figures are low. I think it's something like 3 billion pounds or something now used. It's like 3 pounds of pesticides applied per human being in the United States per year, which is really a huge amount of pesticides for us to be dumping into the environment. Okay, let's get to the neonicotinoids. The neonicotinoids were introduced in the around 1990. And they have the benefit of being a reduced risk pesticide. The EPA considered them reduced risk and fast-tracked them through. The advantage of them is they're also a neurotoxin. They work on your nerves, but they target a different neuroreceptor in invertebrates, especially in insects, than they do in mammals and fish and birds and all that. So they're essentially pretty much harmless to humans and really nasty to insects. Now, if you're a human applying an insecticide, that's really a benefit to you as a human. And if you're a risk assessor looking to protect the population, human population, from pesticide poisoning, and the applicators and the farm workers from pesticide poisoning, the neonics had monstrous benefits. They're neonicotinoid. They come from nicotine, the natural neurotoxin that's found in tobacco plants. Neo means new, and oid means like. So they're nicotine-like. They're modifications of nicotine that bind to the nicotine neuroreceptors in the nervous system, but bind differently between mammals and insects. The other huge advantage that the neonics have is that the plants absorb them. They absorb them through the roots, and they travel up the xylem, up to the top of the plants. They don't travel much through the phloem of the plant. If you spray them on the leaves, depending on the plant and the insecticide, they will be absorbed and also transmitted through the plant. But the main advantage is this systemic action via the roots and up into the plant. And the reason is this. If you spray an insecticide into the environment, 99.9% of that insecticide never hits a target pest. It falls on the ground, it blows away in the air, it goes into the water system, goes onto the plants, but it never actually kills a pest. So it's a very ineffective way of applying an insecticide. With the neonics, by putting them on the roots and having them sucked into the plant, the only insects, are pretty much the only wildlife other than maybe earthworms that are exposed to that are something that actually chews on that plant. If you're not chewing on the plant, you won't be exposed to it. So it's a really slick way of applying an insecticide. So the Neonics became very popular in the nursery industry because it's an easy way to have pest-free certification. If you treat your plants when you start them off as seedlings, they're absorbed into the plant. When the plant's small, the concentration of the neonic in the plant tissue is very high. It will kill insects that feed on it. Then as the plant grows, the concentration goes down. By the time the plant is either used for food or is visited by pollinators, ideally, the concentration in the nectar or the pollen or the fruit is so low to be almost non-detectable. And when I looked at the data from Roger Simons from the Gastonia lab, who does all the testing of food. They go out to groceries throughout the United States, and they take samples of food every single year and test it for pesticides. The neonics are just almost non-existent in there. Even in corn, where it's all treated with it, it's almost non-existent. That was something the beekeepers thought that maybe it got into the high fructose corn syrup of corn. So I actually sent samples in to have them tested, and there was none in that. We'll return to that. So because of this safety and these actions, it became very popular. They became very popular. This is imidacloprid right here. You can download all these maps from the U.S. Geological Service, and it shows in the brown from 1994 through 98, up 2000, up to 2009, how the use of imidacloprid grew tremendously, and this tells all the different kinds of crops that it was used on. So it's an extremely widely used insecticide nowadays throughout most of the world. And right here, just one thing to notice is that we don't see the problems that we've seen with some of the previous class of insecticides. Environmentally, it seems to work pretty well. We'll talk about them in a minute. Until CCD came along. And CCD started, it hit the press in 2000, the fall of 2006 into 2007 when Dave Hackenberg, back in beekeeper in Pennsylvania, his bees started dying. Well, that's really not when his bees started dying. It's when he started complaining loudly about it. His bees actually, and I just saw Dave the other day at the convention. I see him regularly. And we have a kind of a tenuous relationship. You'll see why in a minute. But he actually started seeing problems in 2003. In California, we started seeing problems in 2004. The bees for almond pollination crashed in 2004. It wasn't until 2006 that it made the press. And then 2007, 2008, 2009, that's all you could hear about was just CCD. So CCD became the big mystery then, with all kinds of whacked out theories of why it was happening, aliens coming down and cell phones, and beekeepers immediately took all the cell phones away from their bees and didn't let them text anymore. It didn't help at all. And then in Europe, see, the Europeans, in Europe, the government is afraid of the populace, just the opposite of what it's like in Mexico and kind of between what it is here. And the government's very responsive, so anybody doesn't like something, they just start protesting. So the beekeepers, especially in France, started doing these protests against the neonics, against Bayer especially, also against Syngenta. And this got me really interested. I said, wow, this is perfect. This is just DDT all over again. Here's this giant chemical corporation, pushed this insecticide through, started using it. Next thing you know, the ecosystem starts to collapse. It just, we've seen this story before. So I said, wow, great. I'm going to start writing about this stuff and start researching this stuff and really get on this bandwagon to shut this down. What happened, though, is the more research I did, the less I found any evidence whatsoever to support that hypothesis. I just did not fit. Nothing fit about this whole thing when I looked at the actual data, and when I started talking to other beekeepers. I talked to beekeepers in France and in Spain and Germany, beekeepers all over the United States. I visited the Corn Belt. I went to what I considered the ground zero of neonicotinoid use, and I came up with a very different idea. Oh, here's Dave Hackenberg right here. Now, there's still some U.S. beekeepers, Dave among them, loudly this last week at the convention, blames every single problem on neonicotinoids, all bee problems, which I consider kind of ridiculous. So this is why Dave and I have a little bit of friendly friction between us. So I just put these slides in so you guys understand. The number one problem with bees in every country around the world, other than Australia, is this critter right here. It's called the varroa mite. It's the largest parasite relative to its host of any parasite. It invaded the United States in 1989 or something. Hit California in 1993, and for many of us, it wiped out like 95% of our hives of bees. It was just really, really rough. We had a previous mite come in a few years before, the tracheal mite. We lost about 70%, and we were able to recover fairly quickly from that. And our bees developed resistance, natural resistance to the tracheal mite in about 5 years. So it wasn't a big thing. And when varroa came, I figured, man, it'll be the same thing. We'll just breed resistance to it. It's turned out to be a really, really tough problem to breed resistance to that mite, and it's still the number one problem worldwide on bee losses. If it weren't for this mite, you wouldn't even be hearing about honeybees at all, not at all. This is the number one thing. And the reason is that prior to the varroa mite, the viruses, the insect viruses that infect bees, there's about 20 of them out there, and they're not necessarily bee viruses, they're just insect viruses. Lots of insects and mites, butterflies, all get these. The other pollinators, they share them on flowers, they transmit them. But the only way for a bee to be exposed to that virus is through the gut wall. It had to eat it. So it would go to a flower, it'd suck up nectar, it'd eat pollen that another insect had spilled some virions on. Now, just like you guys right now, if everybody takes a deep breath right now, you've just inhaled thousands probably of virions, of virus particles, okay? And bacterial spores, and fungal spores, and who knows what else from all the dust that are coming in here. But you're not all going to get sick immediately because your body has an immune system and barriers because you're used to breathing, you're used to eating every day that keep those viruses and those bacteria and those fungi from penetrating in and getting into your tissues. And bees have the same thing. It's really hard to infect bees by taking virions, the virions are the actual particles of the viruses, mixing them with sugar syrup and feeding it to bees. It's hard to make them sick. When varroa came, now the mite acted as a vector and just shot the viruses directly into the hemolymph, into the blood of the bee. And the bees have never had to deal with this before in evolutionary history. It just wiped them out. And then what happened over about the next 5 to 6 years, the viruses really rapidly evolved. There's been some neat research in Hawaii about this, that the viruses that learned or evolved to take advantage of using varroa as a vector outcompeted the other viruses, and the other strains of viruses disappeared, and all that was left was just strains that could use varroa as a vector. Now, if we left natural selection to go about this, we wouldn't have a problem anymore. The bees would have evolved resistance to the varroa mite and the viruses. But there wouldn't be any beekeepers left because we would have all gone out of business because it really hits the bees hard. Out of 1,000 colonies, it'll kill 999 colonies easily. And the beekeepers just couldn't take that. So what we did is the same thing you guys do. If you can't take losing your entire crop, you start applying pesticides to deal with the pests, okay? If you let those pests eat your crop and you start propagating the few surviving plants in each field, in a number of years, you would have pest-resistant plants, and you wouldn't have to have pesticides. That's part of integrated pest management. That's part of plant breeding. But the beekeepers did the same thing you guys do. We started dumping pesticides into our hives, miticides into our hives. Up until then, beekeepers would never put a chemical near a hive. We turned into really avid users of chemicals. First pyrethroid, and then an organophosphate, putting them into the hive. It's pretty amazing. One of the organophosphates that we put in, we'd open it up as Coumaphos. We put 2 plastic strips in. So I checked for the LD50 to humans of Coumaphos. If you took one of those 2 strips and put it in a blender and then swallowed it, you'd have a 50% chance of killing yourself as a full-size adult human being. It was that much. We're just dumping this stuff in our beehives. And that was equally bad for the bees. So one of the problems that they're seeing worldwide is beekeepers have poisoned their hives trying to control the mites. The reason is there's 2 main ways to divide insecticides. You can either have lipophilic or lipophilic. Lipophobic or lipophilic. Lipophobic means that well, let's go to lipophilic. Let's lipophobic first. Lipophobic means it's fat-hating, or it would be hydrophilic, it's water-loving. Since we sell honey, which has water as a solute, we can't put any insecticide in that is hydrophilic or lipophobic that goes into honey. So we have to use lipophilic chemicals. And that's typically most insecticides are, because you have lipids on the chitin of an insect's skin, and you want a pesticide that absorbs through that chitinous exoskeleton and goes into the insect. So we use these lipophilic insecticides and miticides. The problem is this beeswax is a lipid, and those chemicals go into the beeswax. And the first generations of miticides that we used went into the beeswax and never came out, just like DDT. They just accumulated until finally beekeepers had to pile piles of combs and burn them because you could not keep bees, or not that it would kill the bees, but you couldn't raise a queen bee on them anymore. They're just toxic combs. So we're learning slowly, and this is still a big problem. The main problem we have is this virus. Here's a couple of mites on a bee. The bees emerge with their wings deformed, so it's called deformed wing virus. And pretty much every bee is born now from the egg with deformed wing virus. If it's stressed at all when it's young, it will come down with the symptoms, and the bee can't ever fly, so it dies off. So this is the number one virus that takes colonies down. There's other ones also. Okay, now there's other things that happen simultaneously with the introduction of Varroa. United States agriculture changed. So here's a breakdown of cultivated land in agriculture in the United States. So let's take a look. How much of this land supplies any food whatsoever for pollinators? Okay, let's stick to the honeybee right now. Honeybee is an old world insect. Corn is a new world crop. Old world insects don't like new world crops. Okay, they weren't never evolved to see them. So bees they don't get any nectar from corn, and they don't like the pollen. So essentially, all cornfields have zero nutritional value for bees. Not only that, but with the advent of Roundup Ready now, there's no weeds in the cornfields. You used to be able to make a honey crop on the weeds that grew in cornfields. There are no weeds in cornfields anymore, so we just eliminated a quarter of U.S. agriculture acreage as bee forage for honeybees. Soybeans produce no pollen for bees, and only nectar under certain conditions. So essentially, corn and soy, not much. Now, some of the states like Iowa and Illinois, 2 out of every 3 square feet of land, dry land, is covered with either corn or soybeans. So if you eliminated 67% of the forage on that land, if you eliminate food, an animal has a hard time staying alive. Wheat, zero nutritional value to honeybees. Hay, well, alfalfa hay used to have some nutritional value, but nowadays the dairies want you to cut it before it blooms, so it eliminates most of that. And if it does bloom, they often spray it with Dursban or something, or Lorsban, to knock back aphids or weevils, and it kills the bees anyway. So we pretty much knocked out most of the hay. Cotton is often very toxic to bees because of the extrafloral nectaries. No food from sorghum, no food from silage, corn. So essentially, out of the entire agricultural landscape, we have a wedge about maybe this size that has food for honeybees anymore. This is the number one problem, our number 2 problem after Varroa facing honeybees nowadays. What beekeepers are working really hard with is try to get to couple incentives for conservation with agricultural programs, so that we've just eliminated all this. Now, this means not just for bees, for pollinators, for wildlife, for birds. We're destroying habitat across the United States at an unprecedented scale. So, of course, any kind of pollinator will suffer. It's kind of funny. I was out in Indiana talking to a beekeeper. He had just had a pesticide kill, and he goes, "Randy, look at this. I saw a butterfly." And he goes, "Wow, you're lucky, Randy. I don't see any more butterflies around anymore. It's got to be pesticides." And I said, "You know what? Butterflies need a host plant for their caterpillars, and I don't see a host plant anywhere." You don't need pesticides to kill something. All you need to do is just eliminate the host plants, and there will be nothing left. So this is happening throughout agriculture. The other thing, this got messed up when I did it, is I made this chart up showing how when you apply a pesticide, how it actually gets into a beehive. And what the bees do, I'm sorry the letters got messed up on this when I transferred it on here, they protect the queen, the larvae, and the pupae. And what they do is they never allow direct contact between the pesticide and either of those. There's checkpoints, and they digest or convert the food or transfer the food to protect the bees in the middle. The only one that gets all the way through is planting dust when you're planting corns. We have a seed-treated corn with clothianidin on it. because of the irregularity of the corn grain, when it goes in a pneumatic planter, it tumbles and it grinds off some of that coating. That coating goes out and either electrostatically just collects on the bees' bodies, or it lands like on clover or something that's flowering on the side. Those foragers bring it back, and they bypass all the checkpoints, and they put it right into the bee bread. So when the bees are newly emerged and come out and go for their first meal of pollen, the ones in the hive before they ever fly, they find that bee bread, and that's what they eat. And the next morning, you find newly emerged bees dead in front of your hive. So the planting dust issue is being addressed. Everybody knows about this. Everybody's working feverishly to take care of this, and I imagine in a year or two this will be taken care of. But the public has learned just to be distrustful of agriculture, of business, of government, of everybody else, just distrustful all over. And man, when they got this thing about, the bees are going extinct because of the neonics, the public just took this story, hook, line, and sinker. Really resonated with them. The new poster child now for environmentalism, instead of being the bald eagle or the pelicans, is now the honeybee, are now expanded into pollinators in general. They never asked the beekeepers whether we wanted our bees to be the poster child, but we got elevated. Now, some beekeepers reveled in this. Man, this is their 15 minutes of fame in front of the TV camera. And if you've seen them on the media, you know who they are, and they're always the ones. Like when I get called, if there's any kind of story whatsoever about bees, I always get contacted by the national media. In fact, it was funny, there was a study released from Harvard recently, and the reporter from Time magazine called me up and said, Randy, I spoke to the researcher, and then I called the USDA to find out what they thought about his research, and they said, you should call Randy Oliver in California. And he says, so my first question is, why would the USDA tell a reporter from Time magazine to call Randy Oliver in California rather than answering the question themselves? I said, because it's not polite for the USDA to criticize somebody else's research. So they just referred you to somebody who would criticize the research. So I get all the calls. Like I got a call recently from Al Jazeera, and they wanted to do a story on honeybees and neonics. I said, okay, before I waste my time, just tell me what your story is going to be. Do you want a beekeeper who's going to tell you the truth, or do you want who's going to tell you a sensational story? I said, so if you do, here's the list of names. And I rattled off 6 names. They said, oh, thank you. End the conversation. So they found the right beekeepers for the right story. They're not really, media's really not interested in the truth. They want a good story. So we now have this public perception issue and media issue, much more so than a scientific issue going on, with really well-meaning people, really concerned about the environment, but being fed misinformation and disinformation and doing these protests. This is scary to me. This is lynch mob mentality. Rather than regulatory mentality, rather than scientific mentality, this is kangaroo court lynch mob mentality, and that is something everybody should be afraid of, okay? Because these guys, they're legislators, because they want to get voted in, they feel, I got to do something. And the legislator knows nothing about all this, but wait, they can sure do something, so then they do stupid things like they did over in Europe with banning without any scientific consensus. So a few of us stood up and said, wait a minute. And I wrote an article called The Extinction of the Honeybee with a question mark. And I traveled to ground zero to the Midwest, and I spoke to beekeepers there. Almost to a beekeeper, they're adamant. They said, Randy, and this is where the most intense use of neonicotinoids in the entire planet Earth, they said, beekeeping has never been better as far as pesticides. Varroa is still a problem. But we don't have any of the pesticide problems that we used to have in the 60s and 70s when we just got wiped out all the time. They said, we love it. We don't know what these people are talking about. So that was my reality check there. That's not me saying it. This is me interviewing on-the-ground beekeepers, and I visited them, and I've been all over, and I checked in other countries also, and I get this from beekeepers all over the world. There's a few activists, but the rest of them have different feelings. I was recently in... I always get Iowa and Idaho, and Iowa. What's the other one? Those 3 states. The one up in the Midwest, and the beekeepers we were having dinner after a conference, and they said, you know what, Randy, there's two kinds of beekeepers in this state. Those who feed their bees protein to make up for lack of food and control varroa mite and make money, and those who have nothing but problems with neonicotinoids. Okay, it's really simple, just two kinds. Either you're a blamer or you get out and you take care of your bees. And I've heard this from all over the place. So there's a lot of blamers out there who just look for anybody to point the finger at other than yourself. Now, let me put a caveat here. I am not at all saying that pesticides are not a major issue to a lot of beekeepers. And neonics can be an issue to beekeepers under certain cases. And other classes of pesticides can be major problems. Insecticides kill insects. Bees are insects. Insecticides and bees don't get along well. But pointing all the blame at neonicotinoids is unfair. You can read this right here from France. It was a major study. And in the country on the planet Earth that was the most anti-pesticide of any country, they couldn't find any relationship. France uses more pesticides per acre than the United States does. Okay, so it's pretty rough over there, but it wasn't the main thing. So let's get back to Paracelsus, who was the father of toxicology. And can everybody just read that? I hate to read for you. Anything is a poison if you get too much. If you drink too much water, you will die. Everything is a poison. When I was teaching kids at the science center I used to run, I'd bring in a 1-pound container of salt, and we'd calculate the LD50. And a 1-pound container of salt is enough to kill 12 kids and the teacher. Okay? Deadly toxic. Serious stuff. What's the most dangerous chemical? One chemical causes more mortality and illness in the U.S. population than any other chemical. Sugar. And some people feed it to their kids. Can you believe that? Most dangerous chemical out there. People are just totally so whacked and not understanding about chemicals and toxicology. All these contain poisonous chemicals. Okay, if we go back and we look at our original stocks where we get our fruits and vegetables, many of them are toxic. And what we've done is we've bred out the natural toxins that allow those plants to fight off pests or fight off the balance of nature, the herbivores. And when we breed out those chemicals so that we can eat them, well, then we've just eliminated their defenses. So then we replace their defenses by us spraying insecticides instead. It's all about the dose. And what I look at is when I'm looking at various pesticide issues with bees, and I look at the toxicology reports, all you need to look at is what the dosage is, what the lethal dose is, or what the no observed adverse effects level is, and how much they're actually exposed to. So I do the calculation. How much pollen does a bee eat in a day? How much nectar does it drink in a day? And how much of the chemical residue is in there? And this is the way I found the neonic thing just did not fit it at all. What's happening now is the scientists are starting to do some pushback now. This is 2 recent ones that came out. I just emailed Norman Carrick, this came out a few days ago, questioning on a major apicultural magazine the number of the studies that they've looked at with the neonics, whether they're actually realistic. This is a really good one, Washington State University on neonicotinoids. Again, coming up saying, you know, guys, we just don't see it. So I've taken a lot of flack from the beekeeping community. I've been, actually was charged, called the most dangerous beekeeper in the United States by one of our leaders of our organizations because I didn't agree with them. On the other hand, I get invited to speak to the EPA, to the registrants, to anybody else who really wants the actual truth about things. So different ways of going about things, whether you want to go through the media or you want to go with people who actually want the actual facts. So here's a grower using a seed-treated corn right here. And the beauty of the seed treatment is he can't screw up the dose. The dose is put on before he gets the seed. And when he puts it in the ground, each seed has just the right amount of dose, which means the registrant can do field trials and test and say, hey, we want the corn, the roots of that corn when it's first growing until it spreads out and gets strong enough, and the stem of that corn to be able to resist pests. And typically you're trying to protect a plant for about the first 20 or 30 days. And then the plant grows large enough that the neonic residues get diluted enough that you lose that. So like with canola, you protect from the flea beetle for about the first 30 days, and then the plant is no longer protected. Same with corn. Once it gets to a certain size, it's no longer protected. The main thing they want to do is if that plant has either pollen or nectar that pollinators gather, you want to get the residues left there to a low enough level that it's not in the pollen or nectar that will cause any problems. So it's pretty simple to do that. You can just, by adjusting the dose on the seed, you can make the pollen and nectar safe for pollinators. Now, you can argue points, and we're learning that. We're having to adjust some of these as we learn more, and I'll get to that some more. So there's a big trial up in Canada. This is Dr. Cynthia Cutler and Scott Dupre. And when Bayer Chemical wanted to demonstrate the safety of clothianidin for the EPA, so they set up they funded this large field trial, and they said, you know what, we're tired of being criticized. We're going to invite beekeeper representatives, we're going to invite seed company representatives, we're going to invite environmental groups, anybody who wants to come, the EPA, the PMRA from Canada. Let's take a look at the trial setup, and if anybody has any objection to the trial, speak now or forever hold your peace, because otherwise we expect you're going to accept the data. And Brett Adey, who's the world's largest beekeeper, and I were invited from the United States, and we saw one flaw in the experimental design. We said, hey, you know, this is a problem. You really should not put the bees in this field. You should move them to a place where there's no agricultural crops around. And at great expense, they did that. Any criticism we had at all, they just changed it. They ran a very good trial. I think it just got published a few weeks ago, and there was no effect on the bees from the seed-treated canola. They do just fine. And the Canadian beekeepers do the same. They email me photographs of these jars with hives stacked this high with honey, and they said, man, if this stuff's hurting us, give me more of it, because we're making money hand over fist. And if there was an effect on the bees, they could not make honey. It wouldn't work. Or they'd all die in the winter, and they don't. The Canadian beekeepers they're like doubling their numbers. They're doing fantastic up there, except for one group of activists in Ontario, a few small-scale hobby beekeepers who have now been hijacked by the Sierra Club and Friends of the Earth, who brought in their professionals. There's a real stink going on there. But there's a whole beekeeping organization there fighting back, saying, no, we don't want any part of this. We're happy with the way it is. So understand, this is not a cut or dried thing. There's a lot of beekeepers who are really unhappy about this blaming here. Now, let's move on to other pollinator insects and other beneficial insects besides honeybees, because honeybees aren't necessarily the best environmental indicator. And the reason is, these are my colonies coming back from almonds. Notice there's a lot of bees in them. They're packed full of bees. These large colonies have a very strong buffering effect. You could take a colony like this. Now, honeybees, around 20 parts per billion in nectar. You start to see some effects from imidacloprid. 50 parts per billion, it's pretty toxic to the bees. You can put in sugar syrup at 100 parts per billion and feed these guys every day for months, and you won't see any problem at all. So if you put a few bees in a cage and fed them a fraction of that dose, they would all die. But if you feed them in the hive like this every day for weeks, you don't see any problem. This is just stymied researchers going, wow, why is that? Why is this buffering effect? So the point I'm making is that these are not necessarily a good indicator for species that don't live in colonies, that only have one generation a year of one individual that has to reproduce. So all these bees here are solitary bees. Well, the bumblebees, they make small colonies, but the other ones are all solitary bees. So one female bee, if she gets poisoned at all, she will not reproduce, and those species are much more environmentally sensitive, and they can be hurt. Some of them have much lower levels of sensitivity to the neonics. This is something that you guys need to be aware of, and I'll be going more of this. So also realize that some of them have a pretty big constituency. People love monarchs. People love ladybugs. So they have a constituency of their own. One researcher, Vera Krishik from University of Minnesota right here, has been a leader of looking at this. So she's been testing the effects of imidacloprid on other insects, starting way back in, this was like 1997 or something like that. Here was a parasitic fly that parasitizes mealybugs right here, and it feeds on nectar, and it was sensitive to imidacloprid in nectar at a lower level than honeybees are. She looked at butterflies. She looked at lacewings, and which is a very beneficial insect for biocontrol, and the neonics can wipe out because they also feed on nectar and feed on pollen as adults. And then she looked at ladybugs. And what she found is when you plant plants in pot with the neonic seed applied as drenches at label application rates, some of these plants, when they come into flower, produce nectar and pollen that had levels of concern. And I agree, I completely agree. They are levels of concern, and this is where you guys come in. Then recently there was 2 events that really hit the press. The first one is when Friends of the Earth went out and they took samples from Home Depot and Lowe's and one of the other big box nurseries and analyzed them. Now, they didn't analyze the pollen and the nectar. They analyzed the foliage of these plants, which isn't quite kosher, but they did that anyway. And they found out some of them, like here's California tomato with 1,500 parts per billion in it of imidacloprid. Well, in canola, it's 2 parts per billion in the nectar and pollen. 1,500 is a sky-high level. As a human being, I'm a little bit concerned about that. That means somebody did not follow label application rates. And when you're going out and buying that tomato plant, it's got a high concentration in there. A couple of the other ones, the Gaillardia and Salvia, plants that are attractive to honeybees, had levels of concern. And this is what started this whole nursery thing that many of you have heard about. The second thing is some idiot pesticide applicator, when the linden trees were blooming in Oregon, in the parking lots, when they bloom, there's a scale insect or something on them that sucks the sap and then drips honeydew onto parked cars. So to prevent that, they will treat those trees to kill that insect. Well, they did it right with a neonic while the trees were in bloom, being worked on by bumblebees, and there was a big field right next door. I talked to the researchers up there. They said, oh God, there's this huge bumblebee population in this field next door, and they're all on these lindens. Well, the thing is, lindens are known to kill bumblebees alone. They have maltose sugar in the nectar, which is toxic to the bees, and at a high enough concentration of that, it'll kill the bees. So the bees working on lindens are stressed, and the application of pesticide on top, or insecticide on top of that knocked them out. So 50,000 bees estimated fell on the ground. Well, this was just a huge media thing, and just galvanized the public against the neonics. And then the science editor of Time magazine phoned me up and talked to me for a full hour because he was going to write an article on that. And then he ignored almost everything I said and put on a very sensational headline there. And I got to tell you, you may have picked this up. I've made subtle hints here. I'm pretty sick of the media for sensationalism rather than trying to do education. They are not interested at all in giving you the straight story. I will tell you that. Don't believe anything you read on the internet. Don't believe anything you read in these magazines. Do the research yourself because they just want to sell sensation. And fear sells. So now here's the deal. There's some really professional media activists that are internet savvy, that are TV savvy, that are magazine and newspaper savvy. They know how to work the system. And they have jumped in and grabbed the pollinator, especially the honeybee, as their poster child. Science comes very secondary, because what happens when you get involved in one of these campaigns, you forget the goal. The goal is to protect the environment. They get so caught up into winning the campaign being the goal. And at some point, they no longer are receptive to objective thinking, because now they're just caught up into winning the campaign. We're all guilty of it. You guys are growers, you all use insecticides, and you've convinced yourself that what you're doing is safe, okay? Sometimes it's not safe, but you convince yourself because you do it. And these guys have convinced themselves that something's terrible. So as a scientist, what you want to constantly do is question everything. Question your thoughts more so than even anybody else's. Make sure that, put any of your positions up for really severe questioning all the time. And be ready to flip-flop. So any single fact should be able to completely change your thinking. You should never get stuck in a position. So it's tough talking to these people sometimes because they're just so stuck in it. I speak in Marin County, California, which is a hotbed of organic. And man, I fear being burned at the stake there. They are not receptive to science or beekeeping practice or anything else because they know what the problems are. And the model would be back in 2007 in the West Coast, Starbucks was big, and environmental groups were concerned about the BST hormone in milk that, for cows to produce more milk. Now, I myself think it was stressing the cows too much, and I was happy to see it go. But what they learned is you don't have to go to the EPA. You don't apply pressure to the dairies. You simply go to Starbucks and say, you know what? With my latte, I'd really rather have BST-free half and half or milk in my latte. And Starbucks goes, geez, big deal. We spend a penny on that. If we can make somebody happy and they're spending $8 for a cup of coffee, man, what? No big deal. So they just told the dairies, hey, you know what? We have some customers who'd like to have BST-free milk. And Starbucks put it out to the dairies, and bang, just like that, all dairies went BST-free. That's all it takes. It takes one retailer to shift the whole industry. This was a huge win for the environmental groups, and I'm a dyed-in-the-wool environmentalist. I'll tell you this right now, okay? I also am the biggest thorn in the side to some environmental groups because I'm a life member of Sierra Club, and I criticize them heavily when they don't back up their environmentalism with science. I'm a science-based environmentalist. So now that they've learned that this strategy works, now they're applying exactly the same strategy to Lowe's and Home Depot. And we'll return to this a little bit later. I want to be really clear about this. These advocates, even if I criticize them, they have every right to be concerned about protecting pollinators and protecting the environment. But I feel that they should do it based upon good biology and good science and data rather than on supposition. So here's your conundrum right now. If you're growing plants and you want to sell them to a nursery, you're going to get feedback from that nursery that our customers are concerned about these plants killing pollinators. And they should be. I mean, if you're a homeowner and you want to plant your garden and you're thinking, oh God, I'm going to plant a pollinator garden, and then you wonder, if I plant this and they grow up and they bloom and the bees come and work with these flowers, am I going to be killing pollinators? Am I going to be killing the native pollinators, the honeybees, or the butterflies in my garden? This consumer has a right to know that. And at this point, they don't. And nobody does. EPA doesn't know, the residents don't know, the nurseries don't know, and this is the situation we're in right now. The only choices they have right now is two choices in our system, in our agriculture system. This is important. We have this organic system, and I'm an organic gardener at home, not certified, but which means essentially I'm a lazy gardener because you don't do anything, you're an organic gardener. You either can get conventional food or you can get organic food, which costs more because it costs more to grow it organically. There's nothing in between, and that's unfortunate. And this is where the agriculture industry needs to step up to the plate here and think, you know, consumers need something between this arbitrary high bar of pure organic, which to me is kind of whack because in California there's just a new certified organic vegetable growing facility that has zero soil. It's under greenhouse, totally enclosed. Because it's totally enclosed, there's no pests, and they sell organic produce, and there is no soil involved in it. It's all just hydroponic. Now, to me, as an organic gardener, where I grew up with Rodale, where organic gardening means you work the soil and you build up your organic matter, and it took me 10 years to get my raised beds with the black soil I have in them now. I'm really proud of my raised beds. I wouldn't sell them for anything. And here is certified organic produce with an energy-gobbling, inefficient greenhouse with no soil. That's a far cry from my idea of organic, but it's certified organic. So I think we need something in between there. Whoops, what do we get here? It's got a mind of its own. Oh, I hope it doesn't. Okay, wait. I know how to do this. I just learned how to do this. Slideshow from current slide. Whew. Okay. This is not going to go away. Okay, so this is something people in agriculture should realize this is happening. And we beekeepers have this problem. You can't produce organic honey anywhere in the United States because for organic certification, that means there can't be any chance that anybody sprayed their roses within 5 miles of your beehives. Well, there's nowhere in the United States where there's not going to be somebody with roses within 5 miles. So when people ask me, well, Randy, is your honey organic? I say, my honey is as organic as the air you breathe. And we are downwind from China in California, so you tell me. Here's the other thing that bothers me, and I speak to a lot of European researchers. It's a cottage industry over in Europe. If you're a grad student or a researcher and you want to fund your lab, all you need to do is put in a proposal saying, oh, we're going to show that neonicotinoids are harmful to X, to whatever, and they just throw money at you. If, on the other hand, you run an experiment and you find out, wow, the neonicotinoid didn't have any effect, you can't get it published. No one will publish it. So we're getting a really one-sided view of the research because money's involved. And it's funny because the environmentalists say, oh God, you can't believe any of the research from the registrants, because it's all phony research, because they paid for it. Well, they don't do their own research. They sub it out to independent parties. Actually, the bias in research is by all of these kind of researchers who are trying to fund their labs. And the way they fund their labs is they apply. This guy right here at the top, he wrote a paper recently that I just tore apart because 3 times in the paper he said the whole paper was bunk, but it was funded by a group called Something for Systemic Insecticides, that they were anti-systemic insecticides. So he published the paper, and 3 times in the paper he said, correlation does not imply causality at all. This paper doesn't really mean anything. So he covered his butt. But I thought scientifically that was really disingenuous. I was really disappointed by that. This is going to be coming out soon. I tried to get an advanced copy yesterday from Vera Krishik. So this is the same Vera from University of Minnesota. And so she's looking at ornamental flowers right here for several more species of insects. And I'll tell you right now, Vera would not be publishing it unless it caused a problem. So you're going to be hearing more about this. So now, what to do about this? I know Bayer and Syngenta intimately because they're interested in getting this straight story also. And I'll tell you right now, I tell them both. I said, you guys, I would be embarrassed to say that I work for PR working for your companies, and especially Monsanto. I said, talk about the worst PR on the entire planet Earth. They're terrible. They're terrible. Syngenta just put a team of scientists in charge of media relations on the Neonics. I said, what are you doing? These guys can barely talk to another human being, They are not media people. You guys are the wrong guys to be doing this. So don't, and I just, Dave Fisher from Bayer, who I'm good friends with. Dave Fisher is one of the straightest shooting guys you'll ever meet. I just really trust anything he says. I said, Dave, Bayer is spending all these millions of dollars on your whole bee program, and you're doing all these presentations at beekeepers meetings, and Dave, they all fall flat. Nobody believes anything you say because you're doing the whole wrong approach. So I'm trying to help them, but they're just, corporate America it's a whole different mindset. It's just really weird. The scientists at the bottom who work on the pesticides, they're wonderful people. They have families, they want to do what's right for the environment, but as soon as you go up the corporate ladder to answering to shareholders, just throw that shit out the window because they have no idea. They don't care about the environment, and they want to make money, and they do a terrible job of selling it. So it's up to you. It's back on you, guys. It's up to you to engage the public, and you need to assuage the fears of the public, and you need to build trust and support for your decision. You need to let them understand. Like I said to Syngenta, I said, forget all these polished brochures. Take a camera and follow Joe researcher home with his family and going on vacation on the weekend and coming in and working the lab and doing what they do to find out, to try to develop safe pesticides, because that's what they do. Your glossy brochures that say, we need to feed the world, I said, you might as well just forget that line. Nobody buys that anymore. That's just a cop-out. So here's some things I got off of a recent meeting I'll show you soon. If you just do what Bayer does and say, oh, no, it's the beekeeper's problem with varroa mite, nobody's going to believe you. You can't put the blame on the others. You got to give an other explanation that resonates with them. So if you guys are trying to sell things to the consumer and you're using pesticides, you better explain to the consumer why you're using the pesticides. They better understand that you're a grower, you've got a family, you're living on the land, and you're going to lose your whole crop, and that you're trying to decide what's the safest way to control insects on your crop. They can understand that because they want to buy that food. They want the food to be gone. So spare no details. Let them know what you need to do. And give them the explanation of why. And keep it simple. So you don't need a lot of science in that. Just a couple things from a greenhouse grower. First thing, and this is what Bayer and Syngenta do, I say, guys, stop denying. The first thing you need to do is admit possible culpability. Okay, let the public know that, yeah, we could be part of the problem. Yes, it's true. It's all these missed opportunities down here. You missed this guy talking this morning. I tried talking to him yesterday morning, and his wife was going to labor, Joe Bischoff, so he was not able to show up. He's a great spokesman, cultivate spokesman from the ag industry who can speak to the public. Okay, EPA risk assessment. Well, I got to speed up here. They know that it's worth a lot of money. I'll go through this quick. You guys can download the PowerPoint. Pollinators are only exposed to the nectar and the pollen. You don't have to worry about what's in the plant tissue. The problem the EPA has is you guys grow too many different species of plants to ask the registrant to get data on all those. So the EPA is not going to do that. And the registrants, Bayer and Syngenta, go, EPA hasn't even given us a list of pollinator attractive plants. We don't even know where to start. So they're working on a list right now. I was on the phone with EPA for an hour yesterday, by the way. Okay, here's the bottom line, straight from the EPA. GLP is good laboratory practice data. That means it's very expensive. They're not going to require the really expensive science. Just simple data will do it. But EPA is not going to lead this. They're throwing it into your lap. This is up to you. You need to provide the EPA with the data. Okay? EPA is not going to regulate plant by plant. So I looked like the label on Marathon, imidacloprid for mixes with the planting on the pots. There's no pollinator warning on that label at all. That will likely change soon. Be aware that's going to happen. Now, when you come up with something, how are you going to guarantee, when you have all this complex mixing instructions, who's mixing it at your nursery? Is the guy going to understand this table? How many plants do you have in a pot? How many container sizes? How many containers you get per bushel of mix? Because if you mix it wrong, you're going to poison pollinators. If you have more or less organic matter in there, it acts differently. You have to account for that. If the plant doesn't grow as tall, that means you have the same amount of chemical in half the amount of plant, which means it's twice as concentrated. How are you going to account for that? And how many species of beneficials are you going to test it on? You notice? This is why EPA is not touching this. And then, if you're putting it up to your lowest paid employee to do the spraying, and he thinks, well, if a little bit's good, a little bit more might be better, that just blows out the window. Then you get those tomatoes with that 1,500 parts per billion of the chemical in them. So let's look forward a bit. You guys are going to need to adapt. The public wants things to change. You're going to need to invest some money. Retailers are going to put you under pressure. The neonics aren't going to work forever. Pests are becoming resistant to them. You're going to have to change treatments at some time. You need to rotate treatments, to come up with new strategies. And you're working against some really strong professionals who are pushing this agenda. You need to be honest with them, and you've got to have data, and you need to be proactive rather than reactive. I'm going to skip through this here. Here's back to the Starbucks. Not all dairies were worried about that. The ones who sold organic stuff, they made more money, increased their sales. So you have a sales opportunity here, a value-added opportunity, selling pollinator-friendly plants. By being able to sell plants with a label saying pollinator-friendly, you can charge more for that. And others are already doing your advertising for you. You don't have to do the advertising. The environmental groups are doing the advertising. Let's see, I'm going to skip to the recent one about what the... Okay, here's a summary. I'm going to let you guys read them. When your lips stop moving, I'll change the slide. Okay, these guys are not going to go away. The public wants change. You need to address those fears. You've got to do it honestly. You've got to know what you're talking about. You've got to be able to tell them honestly that this plant is or is not toxic to pollinators. You got market opportunities. I would be proactive rather than waiting. They've already got a head start. They've got about a 2-year head start on you guys while you guys were sitting and sleeping. They're ahead of you. It's going to be hard for you guys to catch up. EPA is not going to lead the charge. It's going to be you, but they will support you. You're going to have to come up with some other partners, probably some environmental groups. The R4 group back in Baltimore, where they just had the meeting, they can do the research. Other independent labs are happy to do the research. The registrants will help to fund this, but the industry is going to have to take the lead on this.